trying to start. We will probably be fine in time, but yeah. So now we do need the stream to start. Has that started? Then also good morning to the stream in case you can see and hear me. We may get slides at some point. Thank you. So welcome to the second edition of the workshop on programming local first software. After last year's success, we decided to do this workshop again, and where last year we kind of had a good program with, I believe, 6 time slots. This time we accepted 7 plus 6 half slots, which means you get 10 slots total, but we accepted an overall of 13 contributions, which means you get a wide variety of contributions from all kinds of people. So the workshop always was focused on bringing together academia and industry. This was one of our initial goals, where we were like, well, you know, we do a lot of academic research, but in industry they never hear about that, and in industry they do a lot of super interesting stuff we'd like to hear more about. So this was the initial motivation of the workshop. We nailed this goal very well again this year. We added kind of 2 new things that I think worked out very well, in the sense that our contributions cover both like experience reports over a long history, but also new ideas, algorithmic techniques, things that get very technical. And also we have submissions from very senior and very junior people, which is amazing. I think bringing communities together is what I'd really like to see at this workshop, and what we managed. And I mean, I say we managed this, but really it was the submissions of the speakers that made this possible. So thank you very much for all of the great submissions. And by the way, if you're in industry and would like to help with kind of this collaborative spirit, we are also hiring at our research group. So that was my 2 minutes. But this workshop is not just about the speakers, right? It's also about the participants, about all of us, which in practically means that every talk slot has about 50% of the slot is reserved for discussion. And discussion doesn't just mean that you ask questions to the speakers. I would also ask the speakers to maybe ask questions to the audience, and also you may discuss with each other if there's an interesting topic going on. So it should also not be the speaker that has to like keep this going. And one small kind of recommendation for that is I'd like to ask you to maybe for each talk just at least write down one idea or one question that you think is like a key topic, something that stuck out to you, something that you find important or interesting. And if you don't have an idea where to start, I'd recommend going with the core topics of the workshop, which is how does this help with programming, right? Why is what was presented just now something that makes these hard challenges, these problems where no one knows the real answer, easier to tackle, easier to work with? Or these annoying challenges, right, where everyone knows it's bad, but we really want to improve it, go away. And if you don't know how the talk helped in that sense, if you're unclear, maybe write it down as a question. Same for the local first aspect, right? Why is the talk related to local first, right? Why is this, I work locally, I always have my work available, but still can collaborate with second parties, right? Why is that something that's central to this idea? If you're not quite sure, maybe write it down as a question. And if you think like, I don't quite know what my understanding of local first is, let's discuss this. Yeah. And with that, I think we're ready to start the second edition of the Programming Local First workshop. Brooklyn, would you come on the stage and explain us everything about local first in many more words and wonderful examples?
All right. Wow. Thank you, everyone, for showing up early today, and to the organizers for having me. I'm super thrilled to be here. I'm actually really excited for the entire program. I was, going after the schedule was posted, started going through them, and lots of stuff I'm really excited about, and hopefully that I can also tee up during this talk as well. So I'm going to be talking about fielding the local first elephant, a roadmap, hidden gems, and new puzzles from the field. And when I suggested the talk title, I didn't realize how old this phrase was to, this parable of the blind monks and the elephant, I guess, was the original version. I'd always heard it as a bunch of scientists in a dark room, but the original version is, you have 6 blind monks, and the king asks them if they can figure out what an elephant is, and they all try feeling different parts of the elephant, and one feels the trunk and says, it's like a snake, and the other one feels the leg, and it's a little bit like a tree. And none of them can quite agree, but they all have part of the picture. None of them is wrong, right? They just don't have all of reality. To talk to you a little bit about the part of the elephant that I see, my name is Zelenka. You can find me on the internet as Expeed. And I'm the co-founder and CTO at a company called Vision Codes, where we've been doing local first and local first-like things for just under 5 years now. Where we started doing, we didn't have the term local first or lo-fi at the time, but lo-fi secure and user-owned apps directly in the browser, including on mobile. These days, and especially in the last couple of months, we're now much more focused on edge and local first computing in particular. Programming languages and distributed systems are my jam, so I think I may be in the right place today. And I had so much to say, in fact, that my original version of this talk was 179 slides, so I had to cut that back a little bit. Also, despite having, CTO and co-founder, all this stuff, most of the time I feel like a dog driving a car, but in kind of a great way, because I get to go out and range ahead and figure out how do these things actually plug together, and how do we take these ideas and try to actually apply them, and even though it's still just trying to figure out the edges of where these things happen, you get to learn a lot along the way. And as in this comic here, we should write down the things that we discover. We should communicate. I'm so thrilled that we're doing these kind of conferences between academe and industry. So my goals today, are threefold. One, taking stock, kind of give you sort of a state of a union for local first. Looking back, an experience report. So again, this is from my personal experience. Your mileage may vary. You may have had different experiences, and that's totally fine. In fact, I would love to dig in with people throughout today and anybody who comes to the on-conference tomorrow about the different things that they've seen. And I'm going to spend less time today talking about internals of CRDTs and more about the rest of the picture, right? We'll just do local for software, draw the rest of the owl. I want to talk about the rest of the owl. And because of that, I'm going to be mainly looking forward, pointing at problems and solutions for this next chapter, and we'll talk about why I think there's a next chapter in local first. Now, the other thing to be wary of with the, this elephant metaphor, there's another version of this story that is 6 blind elephants and a monk. And the elephants decide that they want to discover what a monk is like, so they get one. And the first one goes and explores and goes and just squishes them. And says, monks are flat, squishy things. And the next elephant goes, yes, I agree. I agree this is a flat monk. It's really easy for us to come up with a single narrative, even though it's just one narrative, right? And flatten it and have that be the only thing that we talk about. I want to see a diversity of narratives and differences in how we think about the problems, especially so early in the evolution of local first. So let's not flatten our monks completely. Something seems to have changed in the last 6-8 months or so. Even this time last year, talking to people about local first, I would have to give them a full definition. And now it's the opposite. People are coming up to me and saying, have you heard about this local first thing? Like, that's an amazing development, right? A few signs of this have been, there was this lovely article in Wired earlier this year, and a couple of weeks ago, a few of us ran a unconference next exchange loop. And we were trying to keep it small, maybe 40 people, and then 200 people signed up, and so we extended that to what the venue would allow, 88. But these are lagging indicators. These show that there's a lot of interest, and it's really grown, and there seems to have been this sudden inflection point that's happened. And when I look around online, I see lots of apps and lots of tools that are claiming to be local first. That's amazing, right? This is now a selling point on the front page of websites, right? This isn't something that you have to define for people and point them at an article anymore. Arguably, local first and local first-like things have been around for a little bit now, right? Apple Notes, Figma, Jupyter Notebooks all have local first features in them. They just don't call themselves big, banner local first software. And my co-founder Boris often says, if Apple open sourced their stack, we wouldn't have to exist, right? We're trying to get to the same things that these large companies have the ability to do, but bring them into everybody's capability. So it's very early days, which means that it's exciting times in both senses. There is a lot of low-hanging fruit. Frameworks are just emerging, so there's no lo-fi lamp yet, right? There's no clear stack that everybody uses that's interoperable. And in many ways, though again, we wouldn't have framed it this way at the time, Fission started to do a lo-fi lamp, right? Turns out that there's a big gap between here and there, which means that it's still today very manual. It takes a lot of investment to do lo-fi in production. And there's very little handholding, which again, super exciting. The people in this room, we get to go and explore and figure out new things. For people that are trying to take this stuff and put it in production, they have to be a particular kind of character. So it's been said that the medium is the message. Also, the medium is the medium, right? So when we had desktop computers, that constrained things in a particular way. All your software was on a single machine. You could move it around on floppy disks. You knew everything that had been loaded onto your computer. Nobody could take it away from you, right? Now we basically rent software in the cloud. In the cloud era, we get a bunch more capabilities from having small computers in our pockets that are always connected, or maybe not always, but the assumption is always connected. And we can do, really great video chats, and Zoom got us through the pandemic, but it also has its own constraints. I don't know what lives on my machine anymore. I don't have full control over it. And now with Local First, we have new constraints, new ways of working, new things that people want to do with it, but it also constrains us in different ways. What are the new degrees of freedom that we're given, but also the new constraints? Historically, and I think probably mainly because we've all had the OSI model shoved at us so much, when I talk to developers, they think of the internet as being the source of truth, and then our local machine being a cache for the internet. So we're going to take some part of the internet, slice it off, and put it on our machine. With Local First software, you have to change that model for them fundamentally, which is, on one hand, simpler, right? It's more cellular. It's more this, individual nodes talking to each other. But because it's different, it takes a bit of, it's a change of mindset. It's a different way for them to have to think about things. And so there's a bit of education that's still involved, even though people understand the term and what it gets them. But they're looking at maybe different parts of this elephant as well. They're really interested in, say, collaborative text editing and not data portability, let's say. I think all of these things can get us towards what's been called previously disorderly programming. I don't know about you, but I don't often get to fully specify my program in advance and know all the services it's ever going to talk to, and then generate my program, right? Ideally from specification. It's messier than that. I need to collaborate with other people. I need to try different things and pull them together. And having that be spread across the entire internet and many different services, and some of those services go down or they change their, like, literally yesterday I was uploading my slides and they say, oh, you've hit your slide limit. I'm like, you didn't have a slide limit before, right? Why is that a thing? Why do I have to change tools now? I should be able to just disorderly interact with my services and with other people. I was talked out of adding this to a previous presentation, and I actually regretted it because then the rest of the day I ended up talking about this basic idea. Crossing the chasm, it's a bit passé now, right? It's been around since literally the 60s, this idea. And basically you have different market segments and different personalities that go along with them. And the book, famous book, Crossing the Chasm, is about this large one in the middle, but we're not quite there yet, right? We're at that little one in the corner, the smaller chasm, between innovators and early adopters. Innovators, people in this room, have a particular personality type. We like working with things that aren't quite finished yet. And as soon as we get them working, we drop them and move on to the next thing. Right? And so you need to cross this chasm to early adopters, right? Who are kind of the cool kids, right? They're going to go out and find the interesting new ideas and take them and popularize them. But it requires a mind shift, right? The things that they care about aren't necessarily the things that we care about. And so we need to find a way of aligning those so that they can take the things that we're building and go and grow the community even more. A different way of expressing this, basically the same idea, comes from Simon Wardley, who was the COO at Canonical, where he developed this other way of viewing this. So essentially on your vertical axis, you have how visible something is, so from totally invisible to very salient at the top, and then how mature a technology is along the x-axis. And things tend to follow this trend. They start out relatively salient, and then they, over time, get hidden and become, dull as dishwater. And that is what success looks like, right? Success is becoming invisible. It's becoming electricity, right? We don't think about the magic invisible force in our walls that, has the lights go and makes, this slide possible, but it goes into a utility. And over time, the value that accrues has this S-shaped curve, where it takes a really long time to get going, and then you hit this inflection point, and then it levels back off again as things become a utility. And this is both, it works in both ways. As you grow, more people become interested in the problem because they can now make money on it, right? But you also have to have something where you can develop in such a way, right? Where you don't just let it die, down there in custom software, where it can become industrialized over time. Then, when things become utility, they enable the next round, right? So you can build on top of this again. Arguably, the cloud is part of what's allowed us to do local first software, right? It's not anti-cloud. It's in spite of the cloud in the article. But it's building on top of these primitives that we've been able to test through cloud software and finding those problems, sure, right? But also being able to say, well, I need to sync. There's plentiful storage now. And I can load as dumb storage all of my local first data right there. And it's available for me to do that really easily. So we're taking this random walk through the solution space. And things are pretty good right now, but it's just gradient descent, right? We're probably going to have to find areas that feel rougher, that are really great for innovators, that hopefully we don't end up in this pit of despair too much, but sometimes we have to go through them to find these higher peaks, to find hopefully this really high peak. And in order to do that, we have to go and explore in a bunch of different areas, right? If we're all going in one direction, we're probably not going to be able to find as much. So what even is local first? I would argue that it's three things these days, right? Convenience, idealism, and a movement, right? A something that came up a number of times, and from separate people, which was interesting at the Local First conference, was this idea that desktop computing was personal, cloud computing was impersonal, and Local First programming is interpersonal, which I've always associated with Next, Steve Jobs' company between Apple and Apple. It's something that inside Fission we've always called postmodern programming, where you can reinterpret data and recombine things sort of at will. But I think it really captures the mindset that a lot of people are coming into Local First with. It's this interpersonal, interactive, even though all of my software runs totally locally, it is about this collaborative aspect. Which makes it not surprising that it shows up in the 7 ideals, right? We have seamless collaboration with your colleagues right in the middle, which I think in this list is an absolute slam dunk, right? There's no question that people in the community have found value with the seamless collaboration idea. These 4 are, I would say, very important. People still really care about no spinners in particular, right? And your work isn't trapped on one device, and the network is optional, right? Security and privacy by default, I think there's still a little bit of work to be done, but people agree with this idea, right? They don't want to be locked in, Facebook, and Facebook can mine all of their data, whatever the thing is. These 2 are what get me out of bed in the morning, the long now, and retain ultimate ownership and control over your data, but they are further out there, right? So these are more in the category, when at least we're talking to people about adopting Local First, in the category of eating your vegetables, right? Things that you should do, but that are the first things that they look to cut when they're making difficult decisions. And that kills me inside a little bit, right? So I think there needs to be a lot more work done on these specific aspects. It's not totally clear how you'll retain ultimate ownership and control when people are trying to build businesses that try to lock you in, right? On the far other side, I think some of these things are absolutely inevitable, right? No spinners because of latency. Bandwidth keeps growing. Bandwidth is actually pretty good. Latency is a physical limit, right? Mark Miller has this great quote that New York isn't getting any closer to Tokyo, right? And despite all of our devices getting faster and more performant, the latency barrier will increasingly dominate applications going forward. Not only is it, in the Local First article, there's all of the latencies between these data centers, I believe it's Amazon's data centers. There's also almost like a social justice or even market-based side of this as well. So this is all of AWS's data centers worldwide. And you'll notice that there's a conspicuous lack of them in these fully uninhabited regions that have quite a few people in them, right? That just aren't valuable enough, right? That don't bring enough money to put an entire data center there. I used to work with a guy out of Nigeria, right? Why can't he have a data center nearby? Why can't he be the data center, right? For him and his family, right? Local First software provides a real benefit to him. He doesn't have to make the round trip to, in an ideal case, I guess it would be down in Cape Town, right? But realistically, it's going to be US East 2, chances are, right? So even for the people that are online, right, that are innovating in these parts of the world, Local First software provides them a real benefit. This helps us get us out of the cloud tar pit, where we're trying to pull together all of these, different APIs and working in their, particular framings of problems, right? Learning AWS is a skill unto itself; it's its own thing. But Local First and things like CRDTs get us out of the muck, right? It lets us code beyond, without regard to time and space. Anything can get merged together, and so we can just get back to the stuff that we actually care about doing, right? Putting cat pictures on the internet. A major part of, at least where Fission started, and that gets me so excited about Local First, is that we can federate data and not apps. So instead of having, slicing with apps that each contain your data, we can slice the data this way and then overlay apps on top of it, right? And share across many of these different applications. And this sounds radical, but this is how your laptop works. You have a file system and you load data into apps. It's when we moved into iOS and Android, right? The mobile era, or in browsers where you don't have that much storage, and until recently you actually really couldn't store in the browser, that this seems like a radical concept. Leslie Lamport has this great quote, slightly tongue-in-cheek, about a distributed system as one where failure of a computer you didn't even know existed can render your own computer unusable. And a few weeks ago, Martin said, well, by this definition, lo-fi isn't a distributed system, which actually ends up being a really great litmus test. I think this is better than at least what I was using previously, which was going into the actual properties for it. So actually to do that and to give an example, and still I would say that this question of what is local first is still open, right? Instead of the CAP theorem, I tend to use this extension PACALC, right? So it says under partition, you have to choose between availability and consistency. Otherwise, so in the case where you're not under partition, consistency or latency, right? So it recognizes that even when you don't have a partition, latency is a thing that you can choose. And a lot of things that we think of as local first are PAEL systems, right? So AutoMerge, ElectroSQL, UCAN, which is a auth system I work on, these are all PAEL. And so that I don't call anybody out, I've redacted this particular project, but it's essentially an operational transform. And the source of truth not under partition. So under partition, source of truth is local. When you're not under partition, it's in a data center somewhere, right? This is the failure of a computer you didn't even know existed, right? If that node goes Byzantine and starts imposing different data, it can start breaking my application, potentially, right? We would have to then say, well, I'm going to break this, say that I'm under partition, and just work totally locally, right? But there is something here where I think we're going to keep seeing this because there's an incentive to put things in the cloud. So while we're talking about just, classic distributed systems things, the fallacies of distributed computing, local first actually solves a bunch of these sort of out of the box, right? Or at least recognizes that they exist, right? Sort of front and center, right? The network is reliable. It's not. By default, we're totally local, right? Topology doesn't change. It's changing all the time. And in fact, we can decide who's in our topology or not, right? We can pull somebody out of our application and remove their rights and see, a different version of our document. Latency is 0. Well, it definitely is when you're working totally locally, right? It doesn't solve all of them. It doesn't solve all of them, right? For example, the network is secure, I think is still an assumption in local first, right? And we'll talk about a few of these as we continue in the talk. There are also some new local first fallacies, or at least things that I see people talking about it this way, right? Fallacy 1, everybody's online, right? Even though it's local first, you assume that the person that you want to pull from, that their data is available right now, and that they're there to manually press a button. Manual pull is safe at all, that you can trust where that's coming from. Local first doesn't suffer Tesler's law. So Tesler's law is that there's a minimum amount of complexity in a system, and at that point you have to then move it around. You can't actually reduce it any further. So it ends up inside of a library, and it's the library maintainer's problem, or it ends up in the application, it's the user's problem. You have to move it somewhere. All programs are weakly consistent, right? So there's a subset of problems that are weakly consistent, but not all of them are. Encryption at rest is secure forever. This one, I had to learn the hard way, basically. So even with at-rest encryption, where you have the keys and they're not held anywhere else, all encryption is breakable, right? Presumably quantum computers will become a thing, and all the standard crypto that we use right now will become broken. And if somebody's downloaded your entire data store, they will get into it, right? So you need defense in depth. And last one is lo-fi can avoid capture. We'll talk about this near the end of the talk, but historically, all systems in telecommunications have had this period of expansion and opening up, and then slow capture. And so the question is, how do we push that off as long as possible and make it so that even when that does happen, we've locked parts of the system open? Oh yeah, there's Larry. Yeah. So from the field, a little bit of my experience from the last, again, not quite 5 years of lo-fi. This is barely modified an exact slide that we gave in 2019 in a pitch deck. So you have users and you have developers, and there's this giant gulf of things in between them, right? So you have the browser and server and data store and all of these things. And if we think that software is going to eat the world, or at least continue eating the world, you now have to train people in Kubernetes and front-end development and back-end development and database design and all of these things, right? With local first, we can collapse this down. We can say, hey, it all lives in this application. The data format is standard, and it doesn't matter which application it runs in anymore. And you don't have to learn all these things. It all runs directly in your browser. You don't have to learn how to deploy Kubernetes. This gives you faster iteration, focus on end users, lower the barrier to entry, and a term that we used to use was ship your mocks. So you can just do some, quick prototyping, and that is a production application. There is no difference. But then Larry showed up again, and people started asking questions like, well, how do I submit forms, right? Well, I guess you could store it in your local store, and then we could do some peer-to-peer sync and do store and forward networks, right? Or we could go to the cloud again. So it flips your trade-offs, right? Your constraints are completely backwards. Doing things that are offline first, syncable, peer-to-peer, like all this stuff just works out of the box. Amazing, right? Portable data, all of that stuff. You want to do aggregation and search and filtering and indexing. Actually, gets much harder, right? Not impossible. And in fact, I think these are problems that we should work on. But they're not immediately obvious how you'll solve them. So, I mean, how hard could it be to build that slide, right? So this is the stack that we put together. So we put this together as a roadmap and then actually got a pretty sizable way through it. And it starts, at the bottom with identity and PKI and some read control with, crypt trees, and, goes all the way up to distributed computing, like literally WebAssembly, moving around the network. I was really surprised to find the parts of this system that people found interesting and useful, and even some of the tiny pieces that I'd pull out and reuse, which again shows to me how early we are in this stuff. So selective sync, really important to people, right? To say, I don't want to pull down the entire data store or even catch up to where I was. I want to grab these specific records, right? An unstructured store. So having, where we landed with it was a little bit like RDF without the RDF bits, right? So having a data store that you can reinterpret in different ways and build CRDTs out of. Portable computation, which is why I do that now as most of my day. And command and mutation control, right? And that's the one that's actually really sort of taken off. Having a auth mechanism that works completely offline, but also networks between different machines and does get you out to resource management, seems to have actually been at least the early success of this stack. Questions we got from day one. Access control when I'm not online for every request. How do I push this into software somehow when the software's not running on a server? How do I tie into existing services that don't have this beautiful algebra behind them? when I want to get access to more compute resources, like a GPU or emailing newsletters, secrets management, but without going full cloud, right? Like, how do I actually do that? I think probably more obvious for this room, read optimization or incremental view maintenance, right? I want my stuff to show up really easily and fast, selective replication, and observability tools, right? I was surprised by how many people ask for observability tools in particular, right? They want to see how stuff moves around so they can debug, and then also see how, introspect how their application's running. One of the really nice things about local first, if you buy into the whole idea, is that you can build reusable tools that work across application sort of as its own app. Again, making an analogy to desktop computing, you often have like a debugger of some kind or an event log that's system-wide. We built what we originally thought was essentially a Dropbox clone, but people were just using this to debug their programs. So they'd have a problem, it wasn't rendering, they're having issues with it, browser tools are only so good. They would load it up in this thing, navigate down to the part of the data store that they were interested in, and they could see, the text that was there or whatever resource was there, edit it. And they were just using it as a debugger. I actually think we need more shared debuggers, right? Things like this that both show off that you can move the data around and that's fine, but make the experience better for everyone. Prior to doing this, my understanding of a very, very high level tech stack was that you had data at the bottom, you put compute on top of that, and then auth sat on top as a sort of as access control lists, right? You'd have your data, and then compute would act as a process behind there. And this did not work out for us in a local first context. We had to swap things around and move to another mechanism, right? Feels a little bit more like tickets than a guard, where our data store was aware of the auth layer and the compute was aware of the data layer. And then things worked. Arguably, there's actually one more layer in here, which is effects and resource management. We'll talk about that a little bit later, but interacting with systems that aren't inside of a total local first paradigm require changing between different levels of consistency, or actually being able to tie together different levels of trust as well. So speaking of different levels of consistency, I originally had the original image from the paper cited in the corner there on this slide, and then I saw May Milano's talk at Papers We Love, and she did this nice reduction. This is, I think, a lot more comprehensible, that there's this hierarchy of consistency models. And they're compatible as long as you find the closest consistency model that is shared between the two, right? So eventual consistency, obviously, can still be made, it's not made linearizable, right? But the same set of events can be put on a linear set of events, right? We can pick an order to put them in. And not all systems have the same, and not all programs have the same consistency requirements. Saying that everything is eventually consistent is really great for a lot of programs. It doesn't work for all of them. And so I think as we're developing programming languages and tools and ways of interacting, there needs to be more work on this in the local first paradigm. Inside fission, we always go back to the COM theorem, which I think in this room is probably fairly well known, but I'll at least state for the video, which is a problem has a consistent coordination-free distributed implementation if and only if it is monotonic. That is to say that it only grows over time and you don't invalidate previous results. When you have to go back and start revoking things, then you have to start recomputing data and do a little bit more coordination about what's in the set and out of the set, right? Which gets me thinking about authorization space, right? What is more non-monotonic than auth? So there are two worlds. There's the world of abundance and the world of scarcity. And in abundance, which is usually represented as a pull-based architecture, you can say, I want to copy all of these different things, right? Computers are actually really good at abundance, right? I can copy files, move them around, all of these things, right? So this is, somebody's giving me access to something, and I'll pull that down because I can see it, right? It's in my world. The world of scarcity is a world of push, and this is saying, I want this data to live over there, or this should be in the group. And people that have been ejected from the group shouldn't be in the group anymore, right? This is all about scarce resources and controlling who has access to what. And it is a way less bright picture, but it's still very important, right? It doesn't make us feel warm inside, but it is unfortunately a hard requirement, right? One of my all-time favorite quotes is that cryptography is a tool for turning lots of different problems into key management problems, which is both horrifying and liberating, because as an abstraction layer, this is really great, right? If we can frame things in terms of encryption and signing, then it doesn't matter how exactly it's implemented. We've already handled that, right? It's already down in the cryptography layer. It doesn't have to live in a particular location. All or nothing encryption, we found did not work, right? People want to have the ability to say, at read time, I want to give this person access to these things, this person access to those, and this access to these others. And because you do cryptography at write time, you need some flexible data structure that lets you do this. You need some kind of, in our case, we picked a hierarchy, but you need something that you can hand somebody keys out of band and say, here you go, here's access to all of this stuff. There's a couple different takes on this. I haven't seen it used a ton in local first yet, which is why I'm going to talk a little bit about now, this idea of a crypt tree. It basically says every node in a graph has a key for itself and all of its children. And so if I give you access to just, in this case, a photos directory, you can see everything below it. Or if I give you access to just a single photo, you can't see its siblings or its parent because it doesn't have the keys for them. And this actually extends really nicely into a data structure like AutoMerge, where you have a series of streams that can each have their own key, and the parent can point down at it and say, hey, here's the key for it as well. So if you have access to this part of the structure, you get everything. You have access to just this one sub area, you only get that one piece. And of course, it has to evolve in time as well. And one mechanism for this, right? So again, not having all or nothing encryption is to say, well, what if we do backwards secrecy? There's also ways of doing this with perfect forward secrecy. Whole other talk, basically. But even with a simple mechanism like using hashing between each step. Now, if you've landed at a certain point in time, you can see everything from that point onwards. And the parents can point at the latest version. So people who are newly joined to the group can only see from that point on. But cryptography is not always enough, right? Like I said before, all cryptography is breakable, right? And all of this is done at write time. So, unfortunately, we have to keep data off the network, in a defense in depth strategy, which means you need to have some way of proving that you're allowed to go and grab these bytes, which immediately leads you into authorization, identity, this entire world. And it's worth noting that there are Byzantine agents, and auth accidents will happen, right? I think this is a pretty illustrative example where, this kid was probably allowed in the room most of the time, but maybe not in this context, right? Being able to control access to resources in a context-specific way is really important in production. And further, we also need to do revocation when it turns out we've made a mistake, right? And pull somebody's access back. We found, and the most straightforward way of doing this was with auth provenance and just baking directly into certificates that, the entire history. One advantage of this is it means that there's no single point of failure. There's no single list anymore. There isn't a group to manage. You can just interact between systems, And that all works, and that's great. So, obviously I work on a particular version of this, right, called UCAN, but we're certainly not the only ones that have explored this certificate capability model before. But as far as I can tell, we're the only ones that have tried to do this in a PAEL system, right? Where, and even going and talking to some of the original capabilities people, right? Alan Karp, people like that, about this. They say like, well, typically in a capability system, we do it like this. Like, well, I need it to be partition tolerant. Oh, yeah, then you definitely need to do it that way. Okay, great. You need rooted authority, definitely. Having capabilities and paths through auth networks, actually, I should probably roll back here, showing that there's paths through the network that are verifiable in the certificate itself being passed around, ends up being the critical component. It's not that you're only delegating access to a single thing, it's that you're drawing paths and saying, I show my intention to automatically redelegate this thing to somebody else. It has some extra benefits like resource satisfiability, right? You can say with this, whoever has access to this capability in a token is able to use this remote resource, or they're a member of this group, or they're able to download this block of data. And further, and something that we haven't actually fully explored yet, but there are a couple folks at Protocol Labs looking into with this, is eigentrust, which is a transitive trust model that uses provenance. And so you can start building eigentrust out of a similar system. This is the most number of citations on a particular slide that I have, and for a reason, right? We'll talk a little bit about co-effects in a little bit, but this slots really nicely into, there's this nice symmetry between capabilities and co-effects for resource management in a totally distributed way. While we're on the topic of trust, how do you trust computation? Well, historically, we've been in the bottom, which way are you facing? Bottom right of this corner, right? In centralized clouds, which is very performant, centralized, right? That's totally works. If I start to receive results that somebody else has computed, how much do I trust them? Why should I trust them? Is it because they're in the group? Is it because they've replicated the computation? Today, what we do in local first is everybody runs absolutely everything, right? It's not super efficient. One way is to not have everybody run everything, and after you hit a certain threshold, say, you know what, we probably trust this. I've gotten from the group, 3 people have agreed on this. It's essentially sort of like a light consensus. Where things seem to be going, and we've had a few people build on top of our platform already, is zero-knowledge proofs. So you get a 200-byte proof that some compute was run correctly. It's also really great if you're doing things like building indices in a distributed way, so that not everybody has to pull down all of the data and build an index. You can get 200-byte proof aggregated across all of these providers that chunks of this were done correctly and that the aggregate was also aggregated correctly. So this is called programming local first software. So I should probably talk a little bit about how to program locally first. Bloom, so the same people that did COM, have this, I think really sum up the situation nicely. Much of the pain of traditional distributed programming comes from this mismatch between an orderly programming model that people are used to locally and the disordered reality that executes their code. To add insult to injury, basically, with this, is that there's also semantics non-preservation between when you start linking different programs together. Right? So if I have program 1 and I have program 2 and I put a bridge between them, my assumptions go out the window, right? Unless I've proven them together, right? Which is pretty annoying, right? I would like to have all of my parts of my application proven that they conform to certain properties. So one way of handling this is to say, well, let's use auth to at least protect certain resources, again, in this world of scarcity, and to recognize the different levels of consistency, right? So if I'm doing pure computation, it's deterministic, great, awesome. That will always work. It's even better if it's monotone, right? If I have something that effectively is a query, I can always roll back over it, right? I get transactionality. If you really want to get fancy, you can do fully retroactive data structures, right? And say like, well, if I drop this event and I go back and I replay, like, what would that look like instead? The really hard one is, again, when you're talking to things that aren't controlled in this beautiful algebraic world, right, of CRDTs, when you need to go out and send an email or post to Blue Sky, right? Where you essentially need to lock your process, have one person run it, because you have exact one semantics, receive the result back, and then communicate that to everybody in a way that they can check, either trust you or check that it was done correctly, right? This is a pretty hard problem. I don't actually think that anybody has like totally cracked this one yet. So, obviously, I'm working on things that are similar. We have edge cases, right? I would love there to be some way of handling this fully. A few minutes ago, I mentioned co-effects and capabilities. One of the topics listed for this group was type systems to help. So two things to say about this. First off, I actually think co-effects do a really nice job with this. They're more general than effects. You can describe any effectful computation as co-effectful. So effects say this bit of computation, talks to standard out. Co-effectful says this bit of computation needs the following things from its environment. It needs to have a standard out, right? Give me a standard out. And bi-effectful is both. Co-effects end up doing a really great job of resource management because you can now say, I need access to a mail server, or I need to have this much memory available, or this variable needs to be in scope, right? And those can have pointers out. So I basically receive a handle and I can write back out again. There's a number of papers, actually more cited on the previous slide, showing that co-effects and capabilities end up being roughly equivalent, right? You can always express capabilities with co-effects. So one of my all-time favorite papers is called The Ghosts of Departed Proofs, right? Where they show a lot of use cases that are normally reserved for dependent types, but they use just new type wrappers, right? Something that's available in a lot of languages. Rust, you can fake them in TypeScript, but you effectively have them in TypeScript, without having to go and build a fully co-effectful programming language, a task that has yet to be done, right? How do we take existing languages and make them satisfy these requirements? I think there's a lot of value. Like I geek out about programming languages. I love new, novel programming languages, right? But there's a lot of value in taking existing off-the-shelf languages, TypeScript, and adapting them to work in this model for us without having to go to the 100% solution. What if we go to the 95% solution? How much faster can we get there, right? And solve the problem for everyone. Elm is a really lovely language. My team used to use it. Lots of teams have tried it and ended up switching out because it doesn't interact with everybody else's code super elegantly, right? I don't want to end up in the same situation with a bespoke new language. Maybe DSL is sufficient, right? I'd also like to see if anybody's exploring leaning into the computational advantages of local first, where you have a lot of different nodes running the compute. One area is Blackboard computing. So we share the results. We break the problem up. We're all sharing results. And as results become available, we're using them in each other's programs. Right? Memoization, propagator state. Propagators are this lovely bidirectional computation model where you can do refinement over time and say, the solution's somewhere in here, and then as other people run it, it gets narrower and narrower. We do collaborative indexing, right? Indexing, aggregation, search, really hard problems in this model. And autocodecs and lenses. So the way that the data is actually literally laid out in bytes, I need to know how to deserialize that. Why do I have to go and find a particular software package? Can somebody write for me a bit of code that tells how to deserialize out of this, run length encoded, really tiny data store to expand that out? Or composable lenses, things like Cambria, that individual people can write the lens just for their the part that they care about, but in aggregate, it gives you a path through the potential schema space. There's these kinds of scale efficiencies are something that I've been really passionate about for a long time. So, as your parallelization increases, your throughput in sort of the ideal is linear. We know from Amdahl's law, it tends to level out, or the universal scaling law, that actually gets worse at a certain point because you have incoherence and data contention mainly. But if we're restricting ourselves, at least for parts of a program, to monotone functions where we can share and trust results from each other, maybe we can do better, right? And this sounds like a utopian vision, but BitTorrent was able to do it for data availability, right? Maybe we can do this for other things that fit really nicely into the local first paradigm. And the last thing to think about for languages is programming languages should, I would even go further than this and say should affect the way that users think, but they always do. Matching a language to a methodology increases the likelihood that methodology will be used. What is the way that we should frame the problems in our programming languages so that people are writing the kind of code that we want to see written? And final section, for fun and profit, sustainable growth and avoiding capture. I have yet to see a truly local first business model. I've seen people try to apply SaaS, or at least hosting models to it. I don't think anybody has really solved this yet. So further research needed. The concern is that Git is this lovely, totally peer-to-peer decentralized system that got captured by mainly GitHub, right? And yeah, you have other options. Again, Fission started in GitLab, and we moved over to GitHub because of the network effects. Nobody could find our code, right? Git doesn't have issues or PRs out of the box, right? And some people have tried to extend it, but over time, because there's these one-way doors that occur over time, you slowly get locked in. And so there's this slow accretion of, taking this beautiful open thing and locking it down. For a fuller explanation of this, there's this great book, The Master Switch, that talks about this in the history of telecommunications for radio, phones, TV, and the internet, though at the time that this was written, it's still kind of, speculative. The one phrase that I heard at the local first Unconf in St. Louis that I thought was interesting was, do it yourself by default and use store-bought when you get busy, right? So it always runs totally locally first, and then you'll pay somebody for hosting. The hope is that they don't start adding a bunch of features that lock you in over time, over the course of 20 years, let's say. And how do we do this without losing our soul along the way, right? How do we make it sustainable and values aligned, right? I don't have answers for this right now, but you may remember near the beginning of the presentation, there were the long now and owning your own data. And those are the easiest things to throw under the bus. How do we prevent that from happening? It's really easy to say, yeah, you get collaborative applications, but then, here comes the airplane, and you get your, user-owned data, right? We don't want to end up in that mindset, and I've seen people starting to go this way, right? What we want is to be actually, to have incentive alignment between these things. So I propose 4 things to check a business model against. Does it empower users to participate? leave without loss, so change providers. You control access to your own data, we call this safety, and provide capacity to others, right? So anybody in the network should be able to provide capacity to others. So to wrap up, we have to remember that there are narratives and that there's a wide gulf between these two, right? Between us each having our own total picture of what local first is versus us all collapsing down into one thing, and there's a sweet spot in the middle there. We still need to go and explore and try different things and evolve, but we don't want to get totally disconnected from each other. We've done an amazing job so far, right? It really does feel like we're in the knee of a curve, which is great. Last year, Peter gave a series of open problems to work on. And I agree with literally everything on that list. The ones that seem closer to me, and again, these are different parts of the elephant, right, are identity trust encryption, right? That entire layer still needs more work. We need lossless data interoperability, a way for managing and working with remote resources that are often not local first themselves, because people still need to interact with the rest of the internet. We need extensible CRDT frameworks. A common complaint I hear is that CRDTs lock you into a particular way and they're not flexible. I think they are flexible. We just need to give people the tools to do that. Collaborative, maybe verifiable computation, especially for indices. Reversible compute or retroactive data structures, and a lot of work on business models. So basically, I want to see a Cambrian explosion of different approaches. Go find some more elephants. Thank you.
So I guess we have a microphone in the middle if you want to ask a long question, but you can also shout them. Maybe, Brooklyn, do you have any questions for the audience first?
I think I asked a bunch of questions through the presentation, so if anybody wants to answer any of those things for me.
One thing regarding the microphone. So I think it would be better if people could ask questions through the mic, because then people on the stream can hear them as well. So, yeah.
One question?
So even if all the data can be recovered and you can theoretically move from one cloud provider to another, there is still quite a lot of technical cost. You know, you have to physically go make all of those operations. Looks like it could be automatized, especially now with the Copilot and things like that. So I wonder if there is any experiment, you know, to make so that our business logic, you know, the one that is unique, meaningfully unique to our application, we can still reasonably write it, but we can write it in some form that then can be wrapped up and twisted in some automatic ways so that now is running on AWT. Is automatically collecting some statistics, how much we pay and how much we would have paid if we were running on the Google service. And then we may transparently be automatically switched without knowing it, you know, on another cloud provider. And that could happen like multiple times a week, ideally.
That's a really interesting idea. I love it. So the first part of the question was, is there some way for us to do this in a, I guess, semantics preserving way? And then the second was about actually moving between providers, right? So the semantics preserving way, I think is actually the harder part of the two. Because typically you have to impose that in advance. I guess the other way to do it would just to get some general sense of, on this machine, you know, people tend to be getting charged this, and on that one, that, and put an abstraction between and move it around. I mentioned that we're working on a distributed compute system right now where we actually do things that are not dissimilar to this. My initial gut reaction when we looked at this, and we're still going to do a little bit of static analysis, was to do look at the cost semantics, look at the cost model for a bit of compute. Obviously, with Turing completeness and whatnot, this becomes difficult, right? So instead what we've done is set so in WebAssembly you can set a fuel limit, say you're allowed to execute this many operations. And the user says, I give you up to this much fuel to run. And then we can start to see, okay, you ran this much fuel and it cost this much at the end. They ran this much and it cost this. And that, we may be able to get some after-the-fact statistics on this.
I have a small counter question on this topic for I guess, the audience. I'd steal one of Peter's tricks. So on programming models, right, and semantics preserving transformation, do you think that existing programming models are great for that, and we should keep using this orderly programming, or do you think we need something new instead, a different programming model that's better suited? Could you try everyone, like, thumbs up for existing models, thumbs down for we need new models?
New programming languages for the win.
So I think we have a somewhat even split, maybe a little bit more on this thumb position. Yeah, thank you.
Yeah. Just really quickly on that. So again, I'm super all for new languages. I was having a lovely conversation before I came up to talk, where Simon Peyton-Jones, one of the creators of Haskell, has this great presentation where he talks about the life cycle of a language and how many users it develops, right? So most languages, it's one, it's the creator, right? If you're really lucky, you get to like 10 or 50. And then there are languages that have, as he calls it, a complete absence of death, right? Java, right? Where even if people don't want to use it anymore, it's too late. We're already invested, right? So yes, absolutely, we should invent new languages, ideally that compile down to these things. My challenge to this group is, how do we use the existing languages with these new models that we're talking about? Yeah.
I think there was one question over here.
I would have a question regarding sustainability. It's the thing that we actually should somehow worry about. And, with the cloud computing movement, everybody was like, yeah, we go to the cloud, there we have green energy, everything is better. We centralize these computations such that we can have a better control of stuff. How does lo-fi fit in there?
It's a great question. Yeah, especially in regions where there isn't green energy, right? Yeah, I mean, I don't have a strong answer. I think it's great to raise. I think that there's a broad question here about the things that we do run locally. People play video games, they watch videos locally. They're pushing all of that over the network already. Having the latency, also isn't free, but it is an interesting and a good point. Yeah, Peter.
So I just wanted to actually say, I think you made a good point already in the talk, which I wanted to return to, which is the traditional model is there's a big cloud computing center. We spend, I don't know, a few $1 million burning up some GPU time to train a 3% better, hopefully, model on cat image generation. But the local first model you propose is one of distributed verifiable compute that's collaborative, right? The sort of challenge model I always use as my reference point is map generation, right? You have OSM tile data. Right now, everybody downloads OSM data and runs the map generation for themselves, right? Each source produces their own thing. If you look at what Google has done with Chrome compilation, which is object file sharing, they have compute clusters that produce object files. And so most developers only have to compile a couple of objects to build new versions of Chrome, which is fortunate because I learned at one point through a very unfortunate series of events that you need like 200 gigs of RAM in your desktop to actually link Chrome. It's like some insane number. I just couldn't actually get my computer to link the damn thing after building it. But that's neither here nor there. The point, though, is that Google has this decentralized let's call it semi-decentralized or distributed compute model where participants in the model contribute compute resources. The institution, the firm, contributes the majority of it, but each node in the system, because for the file you've written, it's faster to compile locally, but for things you haven't worked on, it's faster to pull. And so you can imagine actually that in terms of the total energy consumption budget for difficult compute, that if we can reuse computation done by other people, if we can use new techniques like this portable compute technology stuff that Brooke is working on, or sort of verifiable zero-knowledge proofs of the validity of computation, use CRDT things like Mickeljohn's LASP model for distributing incremental computations over large I think of it as sort of streaming make files, that actually we have the potential to radically reduce the cost of these large distributed computes by being able to reuse resources in ways that are sort of like fundamentally baked into the infrastructure, rather than things that require, identifiable problems at the scale of like Google in order to be able to take advantage of. I would never set up a system like Google's build system for myself, but one could imagine if we had the right primitives that we get this as a consequence of our operating system design, rather than as like a special project that has to be sort of staffed and funded by a very large firm. So, it won't happen by accident, but I do think it's possible to envision a system, like you can imagine this question of distributed indexing, right? You could imagine the people's Google, where, you index your data as you generate it, and then we use, large-scale distributed indexing systems to link these things together. And so, we actually reduce the compute cost overall and the energy cost of our computing infrastructure. So I think you're working on the right things to get us there to some extent.
I really like the point of cloud also has this cost, the local first operators in addition.
I had a comment on what you said, that we should find ways to use existing languages but it's contradictory to your own main point of not being locked behind the door. In some sense, you are saying we are accepting that we are locked behind the door of having to use exactly Java, and that the solution in some sense is that you can use the Java VM or the dotted machine that was designed for that from the start without necessarily using the same language. So connecting with what he just said, an operative system or a virtual machine that are kind of sharing some aspect could be designed to not be able to lock in a specific language architecture.
Yeah, I mean, WebAssembly as a target, I think, has this as a dream, right? Absolutely.
One final question, and then I'll leave you out into the break.
So I have a question on the last slide that you mentioned about extensible CRDTs.
Yeah.
As far as I understand, CRDTs are composable. So what do you specifically mean by extensible effects? Can you explain?
Yeah.
Extensible CRDTs, yeah.
Sure. There's two ways to attack this problem, right? One is have a whole suite of CRDTs that already exist that you compose together, composable CRDTs. The other way, and there's some work we had done inside Fission, and then actually there's a published paper that does this with SQL, and I'd actually really love to talk to some of the folks from Lecture SQL about extending this idea as well, where you separate the raw data of a CRDT from its interpretation. So you have, in our case, this is not the SQL version, this is the data log version, right? But where you have a series of triples, right? That describe some relationship that always turns into, because we were using hash linking between them, always turns into a directed acyclic graph. All directed acyclic graphs are interpretable monotonically, right? So you can then run a program over that interprets it as a row-only set, or as a last try wins register, or any of these different ways. And you can combine different data sets together now and say, okay, these join in this way. I would like to interpret this as a last try wins register, or I just want to count the number of events, or whatever the thing is.
Maybe I'm getting it wrong, but does this sound like MRDTs to you, where the exact representation is decoupled? MRDTs being an evolved form of CRDTs. Have you merged replicated data types, merged replicable data types? Does it sound like that?
Possibly. I'm not familiar with that specific work, yeah. So, there was a paper published earlier this year from I think it was within the PACT group, doing this in SQL.
It's a little bit related to MRDTs, but the kind of composition extensibility is different. So there's tons of things I would like to talk about, extensibility and composability of RDTs, but I don't want to keep you from the coffee any longer. We will have lots more time for discussions later and tomorrow if you join the unconference. Thank you. And thank you to our speakers.